Hi everyone, good morning. So, I'm going to start a new topic that is derivatives. Derivatives is very important that you need this for higher classes also. So, please listen carefully and here I will be doing many problems under derivatives. Okay? So, first of all, you may be familiar with the term derivatives. Derivatives means it is just rate of change. Okay, and derivative we can express it by d by dx, that is with respect to x we are finding the derivative. If it is d by dx, if it is d by dy with respect to y, we are doing the derivative. Anyway, for doing the problems you have to study some formulas, some inbuilt formulas that you have to by heart. Then only you can do the problems related to derivatives. So some major formulas or some important formulas in derivatives are: one is the derivative of any constant. Any constant, it will be 0. That is, if you are finding the derivative of any number, derivative of a number 100, it's 0. Derivative of number 3, it's 0. That is d by dx of any number, any constant, okay, it is 0. For example, if it is c, it's 0. D by dx of 100 or 30, anything, it's 0. Okay, derivative of a constant is 0. That you have to remember. Derivative of a constant is 0. Now, there is an important formula, that is derivative of d by dx of x to the power n. If there is any expression which is of the form x to the power n, and if you want to find the derivative with respect to x, the formula is n x to the power n minus 1. This is very important because in many problems this type of expressions will come. Okay, so that time you have to use this formula, n x to the power n minus 1. Then another equation, that is derivative of e to the power x, that is derivative of any exponential function e to the power x, it is e to the power x itself. There is no change. Derivative of e to the power x is e to the power x. Okay. Now derivative of log x, derivative of logarithm of x, natural log ln of x, it is 1 by x. Derivative of logarithm, it is 1 by x. Then we have the derivative of trigonometric functions, and that also you have to by heart, that is derivative d by dx of sin x. D by dx of sin x, it is equal to cos x. D by dx of cos x is equal to minus sin x. Okay, minus sin x. And d by dx of tan x, d by dx of tan x is equal to sec square x. Okay, then d by dx of sec x is equal to sec x into tan x. Okay, like this there are many formulas, this you have to by heart. Okay, so now we can see some problems, and while doing the problems we can see which are the formulas we are using. Okay, now first of all I will write the first problem. Okay, and also you have to remember some properties of these derivatives. Okay, properties of derivatives means sometimes there may not be a single expression, it may be a sum of two expressions or product of two expressions, like that. At that time how you can find the derivative, that also you have to study properties of derivatives. For example, d by dx of f of x plus g of x, that is if an expression is given like sum of two expressions. Okay, how to find the derivative? So if it is sum, for the derivative also you can find like the derivative of first expression plus derivative of second expression, that is d by dx of f of x plus d by dx of g of x, like that you can find. Okay, d by dx of f of x plus d by dx of g of x. Okay, so that is the sum of two expression. Then subtraction also, if it is a difference of two expression, then also the similar type, that is d by dx of f of x minus g of x will be d by dx of f of x minus d by dx of g of x. Okay, now if it is multiplication, it will be different. For multiplication, here d by dx of uv or u multiplied by v, where u is an expression, v is an expression. Okay, so d by dx of two functions, it will be d by dx of u or v into d by dx of u plus u into d by dx of v. Okay. So here first you have to take the first expression as it is or first function as it is and multiply with the derivative of the second function, plus you have to take the second function as it is and multiply with the derivative of the first function. In this way you have to do. This rule you have to apply. This is called as product rule of differentiation. Product rule. Okay, similarly we have the quotient rule also that we can see later. Anyway, first we can do some simple problems based on these equations or these formulas. First, let the question be, find the derivative of the function 2x square. Okay, 2x square. So here, derivative of any constant is equal to 0. And also you have to remember another formula, that is d by dx of any constant multiplied by any function. Okay, if there is a constant multiplied by a function and if you need to find the derivative of this, what you have to do is you can keep the constant outside. Okay, here the constant is multiplied by a function, not just constant. If it is just constant, we can directly write answer is 0. Here a constant is multiplied by a function. So the constant you can keep outside and then you can find the derivative of the function d by dx of f of x. So d by dx of k into f of x equal to k d by dx of f of x. Okay, and this d by dx you can reduce the notation as f dash of x. F dash of x is nothing but derivative of f of x, d by dx of f of x. You can write as f dash of x also. Okay, so this rule you have to apply here. Here you can see this is a constant 2. And this 2 is multiplied by the function x square. So while finding the derivative, what you have to do, this 2 you can keep outside. This is just like k itself. Okay, 2 multiplied by derivative of the function x square. Function in terms of x that you have to write separately. So here, now this you can find the derivative by applying the rule, that is power rule. X to the power n, d by dx of x to the power n is n x to the power n minus 1. Right? So that you have to use here. Here instead of n, what we have? We have 2. So d by dx of x square, d by dx of x square is n x to the power n minus 1. Instead of n, we can write 2 x to the power 2 minus 1. Right? 2x to the power 2 minus 1, that is 2x to the power 1, or we can simply write 2x. So that is here. Here the constant which we have kept outside, the 2 multiplied by the derivative of x square, it is 2x, that we got here by applying the power rule. So 2 multiplied by 2x, it is 4x. So derivative of 2x square is 4x. In that way, we can do the problems of these types by applying power rule. Okay. Now, the second question, find the derivative of just x to the power 5. Okay. This directly we can apply the rule because there is no constants. There is just a single function which is in terms of x, and this is of the form, the power form, right? So directly you can use the power rule. Derivative of x to the power n is n x to the power n minus 1. And instead of n, we have 5 here. So n x to the power n minus 1. So what we have to do, instead of n, substitute 5. 5x to the power 5 minus 1. So that answer will be 5x to the power 4. In that way, you can find the derivative of powers. Okay. Now, third question. Derivative of 3x to the power 4 minus 2. Okay. Here you can see there are two expressions. Okay. Two expressions, and that is difference of two expressions. And this is of the form d by dx of f of x minus g of x, which already we have discussed the subtraction or difference of two expressions. And you are asked to find the derivative of difference of two expressions. So what you have to do, first find the derivative of first expression minus derivative of second expression. So what is the first expression here, or what is the first function here? 3x to the power 4. And what's the second function? It is 2. So this is f of x, and this is g of x. Okay. So first derivative of the first function, derivative of f of x, that is derivative of 3x to the power 4 minus derivative of 2. Okay. So here the first function, here this is of the form a constant multiplied by a function. So the constant, already I discussed how to do the derivative of these forms. The constant you can keep outside and then find the derivative of x to the power 4. 3, the constant you can keep outside, and derivative of x to the power 4 minus derivative of 2. Okay. So here what is x to the power, derivative of x to the power 4? Here directly you can apply the power rule. So n x to the power n minus 1, instead of n we have 4. So 4x to the power 4 minus 1, it is 4x cubed. Okay, minus, this is derivative of a constant. That is just a number. It is a constant. There is no functions in terms of x. Right? So what is derivative of a constant is 0. Okay. So here we can simplify. 3 multiplied by 2, it is 12. 12x to the power 3 minus 0. So the answer is 12x to the power 3. Okay. In this way you can find the derivative of difference of two expressions. Now next question, find the derivative of 5x to the power 2 plus 3x to the power 5 minus 2x. Okay. So here this is a sum, or this consists of three functions, right? The sum and the difference of three functions. So you can do separately these three. Okay. Here previously we had two expressions. Here just the difference is one expression is extra. So here you have to find each derivative separately. So you can split the derivative, that is dy dx of 5x to the power 2. And what is the symbol here? Plus. So d by dx of 3x to the power 5. And what is the symbol here? Minus. D by dx of 2x. Okay. Now the first term we can apply the rule which already we have studied. Keep the constant outside and then derivative of x square. Okay, d by dx of x square, and directly I can write. After doing many problems you will be very thorough. By looking at the expression itself you can directly write the answer. Okay, so 5 I am keeping outside, x square. X square, applying the power rule, n x to the power n minus 1. Instead of n we have 2. So 2x to the power, here 5 multiplied by 2x to the power 1. Okay, and no need to write the power 1. It is understood if it is just written x, then the power is 1. So 5 into 2x plus, here also keep the constant outside, then find the derivative of x to the power 5. It is n x to the power n minus 1. Instead of n we have 5. So 5x to the power 4. Then here subtraction, here also keep the constant outside. Then n x to the power n minus 1. Here instead of n we have 1. So it will become 1x to the power 1 minus 1. 1x to the power 0. So any number or any variable to the power 0. What is answer? It is 1. Right? So here now we can simplify. 5 into 2x. It is 10x. 3 into 5. It is 15. And x to the power 4 you can keep as it is. Then minus 2 into 1x to the power 0. 1x to the power 0, it is 1. Any variable to the power 0, it is 1. So 2 multiplied by 1, it is 2. So this is our answer. Understood? Now we can do more problems. Let the question be d by dx of 2x minus 3 by 5. Okay, 2x minus 3 by 5. Here also the difference of two expressions. So find the derivative of first expression minus the derivative of second expression. So first expression, that is d by dx of 2x minus d by dx of 3 by 5. Okay. So here the first expression d by dx of 2x. What will be the expression? 2 and derivative of x. Instead of doing x to the power 0 and all, directly you can write derivative d by dx of x. This you can study by heart, d by dx of x. It will be 1. d by dx of x, it will be 1. Okay. The derivative of a variable x, derivative with respect to x, d by dx of x, it is 1. So 2 into d by dx of x, it is 1, and this is a constant. If it is a fraction, if it is a real number, if it is integer, anything, derivative of constant, it is 0. Okay. D by dx of 3 by 5, it is 0. Now we will get the answer is 2 minus 0, and the answer is 2. Okay. It's just 2. Next, derivative of square root of x. Okay. Derivative of square root of x is very important. Okay. Derivative of square root of x. Here, square root of x. What is square root of x? It is x to the power 1 by 2. Right? X to the power 1 by 2. Square root means x to the power 1 by 2. Now, here we can apply the power rule. N x to the power n minus 1. Instead of n, we have 1 by 2. Right? So, 1 by 2 x to the power 1 by 2 minus 1. So, by applying the power rule, we get like this. X to the power 1 by 2. Instead of n, we have 1 by 2. So, 1 by 2 x to the power 1 by 2 minus 1. Now, here 1 by 2 x to the power 1 by 2 minus 1. What is the answer? By doing fraction subtraction, you will get the 2 is the LCM. So, 1 minus 2 by 2. That means minus 1 by 2. So, equal to 1 by 2 x to the power minus 1 by 2. So, that's the answer. If you want, you can again simplify. Here, x to the power 1 by 2 is square root of x. Right? X to the power minus 1 by 2. That we can write as 1 by x to the power 1 by 2. It is any number with negative exponent. Any number, that is x to the power minus n, is same as 1 by x to the power n. X to the power minus n, we can write it as 1 by x to the power n. Similarly, x to the power minus 1 by 2, we can write it as 1 by x to the power 1 by 2. And here, 1 by x to the power 1 by 2. That is, what is this? X to the power 1 by 2. Already we know it is square root of x. So, 1 by 2 multiplied by square root of x. Or, directly we can write 2 multiplied by square root of x. It is 2 square root of x. So, the answer is 1 by 2 square root of x. Okay. So, derivative of square root of x. Derivative of square root of x. Here, directly you can study the answer. It is 1 by 2 square root of x. And the steps for getting that answer is this. Square root of x, you have to rewrite as x to the power 1 by 2. And then you can apply the power rule. And at last, after simplification, after rewriting or rearranging this, you will get 1 by 2 root x. Okay. Now, similarly, we can write what is the derivative of cube root of x. Okay. What is the derivative of cube root of x? Here, cube root of x also we can rearrange or rewrite it as this is x to the power 1 by 3. Square root of x is x to the power 1 by 2. Cube root of x is x to the power 1 by 3. Or any number nth root of x we can write as x to the power 1 by n. This you have to keep in mind. Okay. Nth root of x that you can rewrite as x to the power 1 by n. Both are same. Okay. So, while doing the derivative problems, you have to rearrange or rewrite the equation. So, if it is a nth root, then you have to rearrange the equation as this. Then you can apply the power rule. So, here instead of n, we have 1 by 3, right? So, n x to the power n minus 1. So, 1 by 3 x to the power n minus 1. So, here 1 by 3 x to the power 1 by 3 minus 1. So, the answer will be 1 by 3 x to the power, this will be negative 2 by 3. Or if you want, you can rearrange 1 by 3 x to the power 2 by 3. Here x to the power minus n, we can write as 1 by x to the power n. So, in that way, the derivative of cube root of x, it is 1 by 3 x to the power 2 by 3. Okay. So, these are some problems in which we use the power rule and also the property of derivatives. Okay. Now, in the next session, we can come with few more problems. There are different types of problems in the derivatives. Okay, so that we can see later in the next sessions. Okay, in the coming sessions, we can do many problems related to the derivatives. Until then, bye.